welcome to our channel. Today we will see NXCAM tutorial, rest milling, to remove the material left behind by previous operation. Recommended for roughing out material left behind by a previous operation due to the part stock, tool size or cut levels.
Today we will explain the rest milling operations. What is rest milling? The rest milling is to remove the material left behind by previous operations. We can't do directly on rest milling. Before rest milling, we go to do cavity milling or some other operations, and the material left that operations. The remaining material will be removed by using rest milling method. We will create new model 1, make it rectangular options 60, 100, same rectangular option 60. This corner radius I am putting radius 5. Then finish sketch, go to X2, 20, then extrude by -5 mm, go to subtract model, apply. This sketch we can temporarily hide it. Now we created one model or workpiece. The workpiece is having 100 mm length, 60 mm width and thickness 20 mm. In this workpiece we will cut 60 mm length, 40 mm width, and the corner radius is 5 mm and the depth is 5 mm. By going applications, manufacturing, MCS mill, edit it, machine coordinate system, you can put wherever you like it, you can make it. By default I am putting in center. Then select workpiece, specify your part. This is your part. Specify your block, bounding block. Okay. Then you can say mild steel. You have taken this 1116 code number. That is carbon steel. It is having hardnesses of 100 to 150. It is almost equal to mild steel, so that I am putting mild steel. Okay. Then go to create operations. First we have to go for cavity milling program. Tool we have not selected so far. Workpiece is there, mill finish is there. This is your part, we can check it. This is your blank, you can check it. Next one is your area. Which area you want to cut it? I will cut this area. Okay. Then now we will go for tool, create new tool, go to mill, Here you can type it mill dia 20 cutter you are going to take it 20 underscore you can put for your reference only. Here 20 we have taken it. The length of the cutter is 75 the flute length is 50 tool material is high speed steel. It is already there or you can make it a speed steel. It is not issue. There are so many tools are available. HSS carbide. I have taken HSS material. It's a tool material. The tool number I have given 1. This is the first tool I am going to work with. So far we have selected part, we have selected blank, we have selected cut area, we have selected tool. The next one is tool axis. We have to check it. This JETM axis. Then finish. We are not giving any material allowance for future operations. Just part stock 00. Cut pattern we are using follow. And percentage of tool diameter 40 or 50 or 60. You can go for it. The maximum distance means the depth of cut is 1 mm. We can say here that range depth is 5 mm range. Each and every time it will take 1 mm cut. Okay. Then cutting parameters. We have to check it stock. I am not giving any part stock or blank. Everything I have 0. Non-cutting moves. How to engage the tool. We explained many videos. We can say helical or we can go for ramp. We can go for plunge. Normally the industry people would like to prefer helical or ramp to avoid or damage or broken the cutters. So better we can take it helical options or ramp and same. How we are engaging the tool the same way it will retract, so that defaultly I put same as engage method. Next one is feeds and feeds. Here my tool material is high speed steel, my workpiece material is mild steel. The surface speed might be 25 to 30 max. So I put it 30 meter per minute. Feed per tooth is automatically calculated 0.262 and the spindle speed RPM is 477 revolution per minute. Defaultly this feed rate is 250. You can go for optimistic feed rates. Now we have done it everything. Finally we will generate the programs. We have to verify it. Here see, we have taken dia 20. Please take care. We have taken first cutter dia 20 mm, but our corner radius in our workpiece is 5. So the material, this material will be removed in dust milling. The diameter 20 mm cutter, it will not go inside because the diameter 20 means it can create radius 10. It cannot create or it cannot enter radius 5. This material is still it is there in workpiece. We have to remove the material by using dust milling operations. We will go for create operations. Take it dust milling operations. Program is same. Tool we will select it. Workpiece is same. Finish mill is same. We have to say OK. Here part is same. Blank is same. Cut area is same. In this case, we will change the tool. We have to create new tool because my corner radius is 5. So I am taking the tool N mill dia 10 mm. 10 mm or less than 10 mm only it will remove that corner radius. So I am taking N mill dia 10 mm. Here I am putting 10 mm. My length of the cutter is 75 and flute length is 50. This is second cutter. My tool number is 2. Okay. Method mill finish method. I am not giving any part stock 0. The percentage of tool diameter go for 40 and the depth of cut. Previously we have given 1 mm. If you are interested or if you want to finish or giving some different depth, you can go for 0.5 depth. Means each and every time it will remove the material in the rest of the material. 0.5, 0.5, 0.5. Remaining cutting parameters I will not change it, and cutting moves I will not change it. Feeds and feeds same speeds. Then I will generate the programs. So you see the difference. I am using second cutters. See this corner place, the material is available because previously we are using diameter 20. Now we are using diameter 10. Though the rest of the material which the previous operations left the material in this rest milling we will do. Here defaultly it will take level first, means this will take 0.5, then 0.5, 0.5, 0.5. Each and every time it will take every corner 0.5, 0.5, 0.5 materials. There are two options. One is we can go for level first or depth first. In these operations we selected level first. Now we can go for depth first. What will happen? You see here cut order level first means here it will take 0.5, then 0.5, here 0.5, 0.5. Each and every time it will take the material 0.5 mm. Now I am putting that depth first, means first it will go wherever it will complete 0.5, 0.5 up to 5 mm. Then it will go for another corner. Then it will go to another corner. Then it will go to another corner. Depth first means it will complete one, then it will go to other. We have to generate it. You see that? See here, because of using depth options, it remove the corner material in one corner. Then after completing corner, it will go to another corner. Here the material is found, so that in this rest milling, the remaining material which previous operations or previous cutter left the material, now we are doing or we are removing or machining the materials. Here, see. Now we can analyze it. So see, the navy blue comes 00, means each and every corner and side and floor all material has been removed, so there is no material available, means our operation is done successfully by using cavity mill and rest milling. Another options I am going to explain you by using reference tool. In this case I have to go for rest milling. I have to edit, then all are same. I have to go for cutting parameters and go to containment, then remove this one and put none, and here you will find the reference tool. Means this is very important. What is reference tool? Means by doing this second operations, which operation you have done it first. I did by using diameter 20 mm n mill. I am using first operation, so I have to indicate it. My cutter was 20 mm. Now I am taking that cutter 10 mm. For second operations, I am taking that cutter 10 mm. Previously, the first operation, the cutter was 20. We have to say this was my reference tool. My reference tool means previously the dia 20 mm n mill cutter just done that first operations. Now I am doing second operations by using diameter 10 mm n mill. Now we can go for both operations, cavity mill and rest mill. We can see the difference. First cutter diameter 20 mm n mill has come and it is doing, and it will not go or remove the corner material. So this material will be removed by using rest milling operations. First operation n mill dia 20, then second cutter dia 10. It removes the corner material because the material is available in corner only. Means wherever the materials left by reference tool in previous operations, the material will be removed in current tool by current operations. This is using reference tool method. Now I am explaining that the same rest milling by using giving allowance material. I will save it, then go to save as model 2. Okay. In model 2 I will delete workpiece, machine mill, everything is same. I will create operations, go to cavity milling program. So in this case operation, I go to select these operations. Tool I am taking n mill dia 10 mm only. Tool number 1. In this operations, I am using the same cutter, diameter 10 first I will use roughing, then I will use finishing operations. In this case also you can use rest milling. Rough milling, same diameter 10 mm, 10 mm cutter. In roughing, I am giving 1 mm material allowance for rest milling purpose. The depth of cut is 1 mm, the range is 5 mm, depth of cut is 1 mm. Here, click it. Cutting parameters, non-cutting moves, feeds and feeds, everything we can change it. The main difference is I am using only one cutter, diameter 10. I am going to use roughing as well as finishing operations. In roughing, I am giving 1 mm allowance for finishing operation. That finishing operation will be a rest milling for us. See, this 1 mm material is I am giving allowance. In the second operations, as a rest milling, I am removing the same cutter, I am removing the material. Means I have not changed any cutter size. I am using the same cutter size of dia 10 mm. But this is rest of the material will be removed by rest milling operations. I will copy it. I can paste. Go to create operations, cavity mill. Part is same, blank is same, specify cut area. We go to specify it. Then tool. Previously, for explain purpose, I have taken bigger dia, means dia 20 mm end mill I have taken. But in this case, I am taking the exact size of end mill dia 10. Both I will use for roughing as well as finishing operations. I am going to use two operations, one for roughing, another for finishing. For finishing, I can say I will do it for rest milling. In rough milling, I have given some allowance of 1 mm material for finishing purpose. The finishing purpose is my rest milling. The tool, you can say this is 10 mm tool, exactly 10 mm. And my corner radius is 5. It will completely remove the material. But I will give allowance here by using roughing. I am giving allowance of 1 mm material both side and floor. The depth of cut is 1 mm. The range depth is 5 mm. Cutting feet are same. I will not change it. Here it will remove all materials, but due to I am giving allowance of 1 mm in side in floor, it is not removing that materials. Means it is left the material of 1 mm. This material we will use finishing operations as a rest milling operations. Then go to create operations, rest milling, okay, for blank cut area, everything is okay. The cutter also I am taking that 10 mm cutter only. We can display that 10 mm only. And finishing, and we will not give any material as allowance. We are make it 0 0. The depth of cut is 1 mm, and you can put it 40 or 50 or 60 by using follow part. Then generate the programs. See, this removing the material because we were given 1 mm allowance in previous operations. Now the same dia cutter is removing the material. We can use this type also as a rest milling. Go to now we will summarize that operations. Rest milling in model 1 we have taken different size of cutters. In that cavity milling I have taken dia 20 mm end mill. Then corner material it was not removed. By using rest milling operations I removed this corner material. This is one type of rest milling. By using model 2 I am using cavity mill. Diameter is 10 mm end mill only, and also rest milling I am also taking dia 10 mm end mill only. In this cavity milling I have given allowance for finishing purpose. That finishing purpose the 1 mm material will be removed by using rest milling. So you can use rest milling both using different cutters or same cutters with different allowances. Then finally we will do it post processor. We can take it mill 3 axis, and browser you can go for. You will find lot of post processor available in that library. Decal, Cinemeric inch, Cinemeric 840T in mm, mill 3 axis .pui, the extension file. That output file you can put wherever you would like it. The main thing is that whether the units, the output will be a metric or inch. In this case we require metric, we go to put it metric. This is very important. Then go for OK. Then it is the program output. Here we can read. I will explain that G40 cutter radius compensation is nil or cancel. G17 XY plane and Z will be a vertical plane. Z direction. G90 absolute system. G71 metric system. G91 incremental system, G28 reference, T0 tool number 1 and M06 automatic tool change holder. Cutter radius compensation nil or cancel, G17 plane, X, Y plane and Z will be the vertical plane, G90 absolute coordinate system, G71 metric system, G91 incremental system, G28 reference, Z0. T01 means tool number 1, M06 means automatic tool change holder, M06. G90 absolute system, X and Y, and this we have not given. You can make it here. You can also edit it as per your requirements. You can put 1500 or 2000, 3000 as per cutting parameters available. Then M03 spindle clockwise rotation, G43 cutter height compensation means cutter length compensation, Z 10 mm means it will come 10 mm above the workpiece. Here height compensation you can make it 50 or 100 as per your requirement, and you can put this value in your tool register. Then again it will travel 2 mm above the workpiece, then it will start Z1. Then go to end. Again after completion it will go back up to 10. M02 just it is spindle stop, and you can add it N0900. You can say M30 operation is completed. You can save it. Then finally we will go for simulate the machines. You can go for machine tool view, generic machines, edit, retrieve machine tool. There are lot of machines are available in your library. We will go for milling, and your machine shop may be having Fanuc or head and end or cinematic controls. As per your requirement you can select it. I will select it head and end control. Then where you want to put your workpiece, use part. Here I am putting, this is the base, and I put this base, I put this workpiece on my machine table. Okay, then go to simulate options, go to material removal. For initially we will make it slowly. I made it a little bit faster. In first cavity milling it will give allowance. We have given allowance of 1 mm, so it will not remove the material. Cutter is same, we are using same 10 mm cutters. Now see, I am using the same cutter, remaining 1 mm allowance material which I have given in earlier operations. Now we will complete these operations by using finishing. In this case my finishing operation is a rest milling operations. You can make it, either you can take different cutters or you can take same cutters with different machining operations, rough allowance, semi or finishing allowance. Then I have to remove the machine. Then documentations, you will find program sheet. First cavity mill, it took 5.92. Then second one is rest milling, it took 4.79. By using two different operations, one is on cavity milling, another one is rest milling, the total time is calculated. In this way, you can use the rest milling. Rest milling is cannot do alone, or it should not be in first. First we have to do any one operations, then finally or second or third operation only the rest milling. File, save, we will close it, save all parts.
Thank you for watching. Please like, share and subscribe. And if you have any doubt, kindly let me know in comment section.